Check this out. I have a piece of cardboard with a hole in it and an LED puck. Let me just turn off the light here for a second. And I can make some pretty cool patterns with it. But it would be a lot cooler if I didn't have to spin it myself and put a motor on it. Hi everyone, I'm Rob, and in this video I'll be making a motorized version of this. The idea is pretty simple. Have a light that spins around on one side, have some sort of stencil with holes or some sort of hole pattern on the other side, join it with a tube and put it on a pivoting point so that I can point it up to project on the ceiling or horizontally project on the wall or anything between. And I think this is going to make for some pretty interesting animations. So let's jump straight into CAD. The design is inspired by old telescopes. I have this stencil storage in the bottom, then the pivoting point to point it up and down, and then the main body is a tube with threads on each side so I can use different types of lids, and the front lid is made so I can quickly change the stencils. Let's start with the stand here. We have a square nut embedded in the 3D print, one bolt, and then basically all the parts are using 3D printed threads. So that's about it for the stand. Now for the tube I actually inserted the nuts while it was printing, and then on each side we have threads so I can just screw these things on. Now the front lid is from two parts and then screws on top of the tube as well, and then here this is where the stencil goes in. Click. I also have these bolt assemblies that are basically just a hex bolt sandwiched between two 3D printed parts. And these bolts hold the assembly together and allow me to adjust the pivot angle. So that's the main assembly done. Let's look at the electronics. My first idea to make the spinning light was just to connect the battery inside the LED puck to a motor and have a very simple circuit. But I don't like the fact that it uses AAA batteries, so I thought maybe I could use a separate battery for the motor only. But that also didn't make a lot of sense because now I had two different batteries inside. So let's just ditch the original LED puck idea and make a custom light with an LED ring and a microcontroller. And, as a bonus, I get to control the speed of the motor as well. Here is the solution. Battery, switch and LEDs on the top, and on the bottom we have the motor and a prototype board with the microcontroller, the IR receiver, and an overkill MOSFET to drive the motor. I can control it with the same IR remote as the LED puck, change colors, light patterns, and motor speed. But after testing it a bit, it became obvious that the battery placement is not great as it occludes the LEDs right next to it, which is especially noticeable if I turn on a different pattern, for example this one, where the LEDs are right next to the battery holder. This produces occlusions in the pattern, which you can see here when I switch from 3 LEDs to 4. Also, this is the slowest speed I can get right now, and if I go slower it completely stops. And the fastest speed is too fast, I think. So this is the second version. On the top we still have the LEDs, but the battery was moved to the bottom. The motor is still the same, but now we have a transmission which reduces the speed by 4, and instead of having the shaft directly bolted to the lid, it uses magnets. Look at how smooth and slow the movement is now. But to get slow rotation, I'm still running the DC motor at low voltage, and that causes inconsistent speed, which created a distracting effect on the animations. I switched to a stepper motor to solve it. They offered true constant speed control, though I initially avoided them because of the noise. Plus, these cheap steppers are nearly identical in size to the original motor, so the redesign was minimal. Alright, enough about the electronics. Let's see it in action. First, let's start with just one LED and then gradually increase the LED count. Then it comes to life as I turn on the motor. With this, I can make all sorts of different visuals by changing the light pattern or the physical stencil. And I did make a bunch of them. All that's left to do is to sit back and enjoy the show. It is a little bit noisy because of the stepper motor, between 37 and 37.5 decibels, but it's something I can live with. There's obviously a lot more light and stencil combinations that I can use, but to keep the video short, let's just go with this. I consider this to be like version 0.1 or something that's not quite finished, but still, if you want to check out the model and maybe try to build it yourself, check out the link in the description. And I will probably get back to it with a custom PCB, with a better driver to make the motor more silent, because right now it's a little bit noisy because of the stepper motor and the basic driver. So hopefully in some future version it will be a lot better. I hope you liked it. See you in the next video and keep building cool stuff.